This is the EV3 programming software, and in this video we will be introducing block programming. So over here is the start block, and you drag on other blocks on there, and the program is run in the order of which the blocks are dragged on. So under all these different tabs, you can find the blocks that you'll be using. So starting with action blocks. So just like this, I drag them on. So these are different kinds of motor blocks. Over here at the top you can choose the port for which the motor is connected to on the EV3. And on these blocks there are different kinds of parameters which you can choose yourself. Like power is this one, and rotations or degrees or seconds, you can change that here. And break at end, which is a yes or no value telling whether you want your motors to completely stop after the action is complete. So over here is a block for the medium motor, here's a large motor, and here is a move steering block, which it moves both of the motors at the same power, but it can rotate in place by choosing the steering. And over here is move tank, where you can choose the power for both of the different motors. Under this orange tab are the flow blocks. So this is the start block, which I mentioned earlier. And here is a wait block. So you put it between two actions, so it waits after one action to complete the next, and it could wait for time for like a number of seconds, or you can make it a sensor. Once it detects something, then it carries out the next action. This is a loop block, and it basically repeats an action until something happens. So that could be unlimited, so that it keeps repeating the action while the program is running. Or it could be count a number of times that you want it to repeat the action, or logic, or time, or a sensor once it detects something also. This is a switch, so what it does is basically it's like if, so it has a number of cases. So if something happens, so the default is a yes or no. So it's either if something happens, you put an action for what you want it to do if something happens, and what you want it to do if it doesn't happen. So that could also be sensors, or if you put it in numeric, then you could have a different number of cases. So you could keep adding cases like this. This is loop interrupt. So you put it inside a loop and it stops the loop. So normally if you just put it inside a loop by itself, it would be pointless, because then it would start the loop and terminate it immediately. But if you put it inside a switch, then if something happens, then it's like another way to end the loop. Yellow blocks here are sensor blocks. You'll notice that some of the blocks, instead of having numbers, they have these shapes at the bottom. So what these shapes are, you can drag them over, and they're actually wires, and you can plug it in to in another block where there's an indentation of the same shape. So some of them, there are these semicircles and triangles, mostly semicircles. So you can plug it in to a block which has a semicircle indentation of the same shape, basically. So what this does is that this is the output from one block. It's using that as the input for another block, so it transfers data. So the semicircle ones are meant to represent a number, and the triangle ones are meant to represent values, logic values like yes or no. So the point of a sensor block is just to detect the value, and you can use it for different parts of your program, such as motions, such as motor movement, or you could also use it for loops and switches, and etc. for many different things. So out of all of these sensors over here, most of them over here, they can be used to measure or compare. So over here is brick buttons. So it measures or compares a pressed brick button on the EV3. Here is a color sensor, which can be used to measure or compare color or light intensity, reflected or ambient, and you can also calibrate this. This is a gyro sensor, which, keep in mind, does not come default with the program and you have to download it. But it can be used also to measure and compare angle and rate, and also you can reset it. This is the ultrasonic sensor, which you can measure and compare proximity, beacon, and remote, but beacon and remote are for remote controls, which we aren't allowed to use in FLL, so you'll mainly be using proximity. This is motor rotation, so you can measure or compare degrees or rotations or current power, or you could reset it with this block. And this is a timer, which you can measure and compare time, and again you can reset it. And finally, this is the touch sensor, which you can measure or compare the state of the touch sensor, so whether it's pressed or released or bumped. The red blocks here are data operations. So this is a variable, and with the variable block you can write or read variables as text, numeric, logic, numeric array, or logic array, and you can always add a new one at the top. This is logic operations. So the logic operations you can do here are AND, OR, XOR, NOT. So you input two logic values, and the output, it also gives a logic value. This is math. So you input two numbers, and what it could do are these operations: add, subtract, divide, multiply, absolute value, square root, exponent, and advanced. And in advanced there are 4 variables, and you can do all these advanced operations with them. This is compare, where the input is 2 different numbers and you compare the numbers, telling whether they're equal to, not equal to, greater than or equal to, less than, or less than or equal to. And again, the input are numbers and the output is a logic value. This blue tab is advanced. So these are a bunch of random miscellaneous blocks which have very complicated functions, and most likely you probably won't even need to use them. And finally, my blocks. We'll be talking about them later, but my blocks are basically programs you make yourself, and you can drag them on as a block to represent a function.